Hello and welcome to this lesson on isotopes. In today's lesson, we will understand the concept of isotopes and recognize that isotopes of an element have the same number of protons but different numbers of neutrons. So far, you've learned about the nuclear model of the atom, which describes the atom as having a small, dense nucleus composed of protons and neutrons, with electrons surrounding this nucleus. Additionally, you know the difference between mass number and atomic number. The mass number is the total number of protons and neutrons in an atom's nucleus, while the atomic number is the number of protons, which uniquely identifies an element. We've also briefly touched upon the idea of isotopes in our lesson on mass number. Building on this foundation, today's lesson will introduce the concept of isotopes. Isotopes provide insight into the details of elements and their atomic structures, allowing us to better understand phenomena such as radioactive decay and relative atomic masses. Isotopes are atoms of the same element that have different numbers of neutrons in their nuclei. This means that while they have the same number of protons, their mass numbers will differ due to the variation in the number of neutrons. For example, hydrogen has one proton, but the number of neutrons it has can vary. Here we can see three different hydrogen isotopes, each with a different number of neutrons, and therefore different mass numbers. The atomic number of an element is determined by the number of protons in its nucleus. Since isotopes of an element have the same number of protons, they share the same atomic number, which is what determines the element's identity. However, the mass number, which is the total number of protons and neutrons in an atom's nucleus, varies between isotopes because of the different numbers of neutrons. Isotopes are typically identified by the name of the element followed by their mass number. For example, carbon has several isotopes including carbon-12, carbon-13, and carbon-14. These names indicate that in addition to having 6 protons, carbon-12 has 6 neutrons, total mass number of 12, carbon-13 has 7 neutrons, total mass number of 13, and carbon-14 has 8 neutrons, total mass number of 14. Despite the difference in mass numbers, isotopes of an element exhibit the same chemical properties. This is because chemical properties are primarily determined by the electron configuration, which is not affected by the number of neutrons. Hence, carbon-12, carbon-13, and carbon-14 all behave the same way chemically. However, some isotopes might be unstable and undergo radioactive decay, making them much less common than other isotopes. In our example of carbon, carbon-14 is unstable, which affects how often it is observed in the real world. To get an idea of what we mean by this, carbon-12 makes up approximately 99% of all naturally occurring carbon on Earth. Carbon-13, another stable isotope, makes up approximately the remaining 1% of naturally occurring carbon. Carbon-14, an unstable isotope, only makes up about 1 part per trillion of naturally occurring carbon. That is approximately 10 to the power of 10%. For GCSE chemistry, you do not need to know much about unstable isotopes or radioactive decay processes, but it is interesting nonetheless. In today's lesson, we delved into the concept of isotopes and their significance within the atomic structure. We learned that isotopes are variants of a particular chemical element that have the same number of protons but different numbers of neutrons. This means that while isotopes of an element share the same atomic number, they have different mass numbers. By visualizing isotopes through diagrams and models, we gained a clearer understanding of how the atomic structure can vary within the same element. This lesson has enhanced our grasp of atomic mass and the role of neutrons in creating isotopic diversity, providing a solid foundation for further exploration of atomic structure and the periodic table in future lessons.